Welcome dear students for the online session of System Software for the program BCA of 3rd semester BCA prescribed by the Kuvempu University. So today we are having the session number 4 from unit number 2 of the subject System Software. So in this session we will be discussing about one of the very important and very crucial part or understanding or learning in our assembler, that is the pass1 algorithm of assembler. So before going on to the algorithm for the pass1 of an assembler, let us have a recap of our previous class. In the previous class you got understanding of the format of databases. That is, in the previous class, I think you all remember, we have learnt about what is this MOT, that is machine operation table, and POT, that is pseudo operation table, and what is the format of data which is been stored in MOT as well as in POT, and which is being used in pass1 and which can be used in your pass2, or which particular table can be used both in pass1 and pass2. So with that understanding of databases, today let's understand what we are going to do in this session. So the overall learning objective of today's session is the student will be able to understand the algorithm for the pass1. So the session outcome, at the end of this session the student will be able to understand the algorithm for the pass1. So let's start discussing about this assembler pass1. See, the assembler, it works in pass1 as well as in pass2. You know this thing. So let us see how the pass1 is going to happen. So in the pass1, the first and primary thing is to define the symbols. So the algorithm for defining the symbols in the pass1 is primarily we are using a special variable called as LC, that is location counter, which is set to the first location in the program, and initially this location counter value is relatively set to what? 0. That means when the algorithm for the pass1, the relative address is 0 for our location counter initially. Then this assembler will start reading the source statement. So whatever the assembly language we have written, that will be start read by the assembler. Now the thing is what we are going to do in this pass1. So I'll tell one by one. The first one is the operation code. We call it as an opcode field is scrutinized to find out if it is a directive pseudo operation code or not. So first, once the source statement is read, the opcode field will be verified to find out whether the read statement component is a directive pseudocode or not. Now assume that if it is not, that is it is not a directive pseudocode, then what the assembler has to do? So here the assembler will have the table of machine opcodes which will be investigated to discover a match for the source statement's opcode field, and if you get a matching entry, then the matched entry states the length of the instruction, that is what is the amount or the length of the instruction are being scanned during the pass1. Next thing is the operation field is further scanned for the occurrences of a literal. If after the scanning, if it finds a new literal, then it is entered into a literal table for afterward processing. So this is another important thing. So once the scanning is done, you have to verify whether it's a literal, and if you have found a new literal, then you have to enter it into a table called as literal table for the next processing there. So once you are into this particular process, what we have to do is next the label field of the source statement will be inspected for the presence of any symbol. For example, you are having any special symbols there, and if there is a label, the symbol is saved in the ST, that is your symbol table, along with the existing value of the location counter. This is very important thing, because when you are saying the symbol, even you have to know what value is being stored at that particular time by the location counter. So finally, the current value of the location counter will be incremented by the length of the instruction, and a replica of the source record is saved for the use by the pass2. That is, another copy will be created of that, and it will be further stored for the usage by the pass2. So I think you're clear about these three basic fundamental steps in your pass1 there. So next, the same above sequences which we have discussed now, they are repeated for the next instruction. The same thing is being put up in a loop. The same thing we are going to store some values in the literal table, symbol table, catching the value of a location counter and then incrementing it. Okay, so the loop depicted is physically a small portion of a pass 1, although it is the most significant function there. So I think you understood what we are going to do when we are discussing about the algorithm for the pass 1 when defining the symbols. So let us have some simple MCQs regarding today's session. Okay, let me have the first question for today. Which of the following is not a function of pass 1 of an assembler? So you have to tell which is not being done by the pass 1 of an assembler. So the option 1 is generate the data, keep track of literal LC, then remember the literals, remember the values of symbols for the pass 2. So just now we have told that in the pass 1 we'll keep track of your location counter. B will be done by pass 1. Even it is going to remember literals using literal table, and even the values are stored for the pass 2. Therefore we can tell that the answer for the question number 1 is A, that is your generate data. The answer for the 1 is A, that is the generating data is not the function of pass 1 of an assembler. So we'll go for the second question. Pass 1 assembler generates object code, whether it is true or false. Yes, pass 1 assembler is going to generate something which is called as what? Object code only. Next question is, which is not the common database in both pass 1 and the pass 2 assembler? So in the previous class you have learned that we are going to use the MOT, POT as well as ST, but in the pass 1 we are not going to use what? The BT. Okay, so therefore the answer is what? C. Okay, so we'll move for the question number 4, and the question number 4 is, the literal table is a variable table, whether it is yes or no. Variable means the value will be changing. Yes, as soon as you will be entering into the next and next scanning loop, then the value will change. Therefore the answer is true. And the last question is, which of the following is not the basic assembler directive? I think you got the answer. It is nothing but exit, because when you are writing an assembler directives, you will have the mnemonics like start, end and byte, but we don't use what? Exit. So dear students, I think in today's session you were able to understand the algorithm for the pass 1. So for the further reading, you can also refer the book authored by John Donovan, and the title of the book is System Programming.